Now we've got some more revision. This is the short answer section in the sheet that I handed out. And the first one, we have P equals 3H plus 10. And we want to make H the subject. So what we need to do is to shift everything that's on the same side as H. So BODMAS backwards would be identifying this positive 10. So we do the opposite of that, which is negative 10. We do that to both sides. So on the left-hand side, we now have P take away 10 is equal to only 3H on the right-hand side, and that's because the positive 10 and the negative 10 have cancelled each other out. So the next thing that we need to do to leave H on its own is to get rid of that 3. It's 3 times H, so the opposite of the times is divide, so we're going to divide both sides by 3. That'll cancel down like so, and leaves us with H is equal to P take away 10 over 3, and that's the answer that we're after for the first one. The next one that we have is H equals 20 take away 2t, and here we want to make t the subject. So what we need to do is to get the 20 to the other side. It's a positive 20, so we're going to take 20 from both sides. So we end up with H take away 20 is equal to negative 2t. Don't fall into the trap of losing that takeaway in front of the 2t, it must stay with it. The next thing that we need to do is to get rid of that negative 2 in front of the t. So we're going to divide both sides by negative 2. The negatives will cancel down and the 2's will cancel down. We end up with t is equal to H take away 20 over negative 2, or to get rid of that negative 2 on the bottom, we can swap the order of things on the top. We basically multiply both of them by the negative. So that would become negative H positive 20 over positive 2. So we've multiplied everything on the left-hand side by negative, or times the top and the bottom by negative. And what we'll do is we'll just swap the order of those around on the top there. So we end up with 20 take away H over 2 is equal to 10. And that's the answer to the second one. And the third one of these for question 1, we have S equals P I plus RT plus 7, and we want to make R the subject for this one. So the first thing I'll do is actually shift that 7, which is on the outside. If we're doing BODMAS, we do the brackets first and then any additional subtraction last. When we're going backwards, any backtracking, we look at the additional subtraction first. So we're going to take away 7 from both sides. So we end up with S take 7 is equal to P bracket I plus RT, and those are cancelled down on the end there. Next we're going to divide both sides by the P and cancel that down. So we have S take 7 over P is now equal to I plus RT. We're wanting to keep R on the right hand side, or get rid of everything that's there. So now we've got rid of the bracket. We now again look for any additional subtraction, which is the I. So it's a positive I, we'll take away I from both sides. That'll get rid of that. So we end up with S take 7 over P, take away I is equal to RT. And the next thing that we need to do is to divide everything by the T, which is on the right hand side. That'll cancel that down there, and if I can just shift everything up so we can have a look at what's going on there. What happens with this left hand side is we end up with S, no, red's alright, isn't it? S take away 7 over PT, take away I over T will be equal to R, And if we want to get the left-hand side and make it into one complete fraction term, we would then take the second part and we multiply the top and the bottom by p. That will now give us a common denominator on the left-hand side. So that will give us s take 7, take away pi, all over pt is equal to r. And that's the answer that we want for that one. Now the next question that we have is we're going to evaluate some equations. So we've got 2 over 5x and we've been told that x is equal to -2. So that basically means that wherever we see x, we substitute -2. So this will be equal to 2 over 5 by -2. We could evaluate the bottom line if we wanted to, but I think it's easier to cancel down. So 2 goes into 2 and leaves you with 1. So this will be equal to 1 over -5, or it's just equal to -1/5. That's the first one. Now the next one that we have is 2 over 3x, where x is equal to 3/4. Now, we're going to have a fraction on the bottom here when we substitute this in. So, what I'm going to do is, I'm just going to rewrite this first bit as 2 over 3 divided by x. It's actually the same thing. So, 2 over 3x is the same as 2/3 divided by x. But x is equal to 3/4, so we have 2/3 divided by 3/4. And if you can remember back to year 7, if you're dividing by a fraction, what you need to do is we invert the second term, the second fraction, and we'll turn it into a times. So this now becomes 2/3 times by 4 over 3. You multiply it through, 2 times 4 is 8 on the top, and 3 times 3 is 9 on the bottom. So our answer for that one there is 8/9. And the next one, we have 1 over x squared plus 3, where x is equal to 1/2. Now, I'm going to substitute the x equals 1/2 into this, so it will be equal to 1 over 1/2 squared plus 3, which is equal to 1 over 1/2 squared is 1/4. And what I'm now going to do is I'm going to combine the denominator here and try and turn it into a single term. And the way that I'm going to deal with that is a bit like fractions. So the next line, this will be 1 over 1/4 plus 3 as 1/4 is 3 in terms of quarters is 12 over 4. And again, we'll simplify the denominator as 1 over 1/4 plus 12/4 is 13 quarters. Okay. Now, if you remember what we do with fractions when we divide by a fraction is I'm just going to take this up to here so we've got a bit more space. I'm going to rewrite it as 1 divided by 13 over 4. And as I was saying, if you remember what you do with these is that you invert the second term and we turn it into a times. So this will be equal to 1 times 4 over 13, which is just equal to 4 over 13. And that's the answer that we want for that one there. Now for question 3, we're looking to solve a few equations. So the first one here, we have 2 take away 3x equals 6. If we're going to solve this one for x, what we want to do is we'll firstly take away 2 from both sides. That will cancel that down. Leaves us with negative 3x is equal to 6 take away 2 is 4. And the next thing we want to do is divide both sides by negative 3. The negatives will cancel down, the 3's will cancel down. Leaves us with just x on the left hand side equals negative 4 over 3 as our improper fraction on the right hand side. Now when you're doing these sorts of questions, it is important that we don't lose this minus in the middle here. A lot of students would drop that off, but you need to make sure that that continues down to the next line so that you don't make a mistake and get the wrong answer. So just keep an eye on that. Again, we'll be solving for x, so we've got 3 take away 5x equals 6x take away 22. Firstly, I'll look at the x terms, and I'm going to identify which is the smallest or most negative of the two. So I've got this one here, and this one here. Now I've identified the 5, or I could treat it as negative 5, as being the smallest and most negative, so I'm going to add 5x to both sides. And minus 5 plus 5 will cancel those out on the left hand side, which will leave us with 3 is equal to 6 plus 5 is 11x, take 22. Next, what I want to do is to shift the 22 to the other side. It's take 22, so we're going to plus 22 to both sides, and they will cancel down. Leaves us with 25 is equal to 11x, and the final step that we have is to divide both sides by 11. Now the 11s will cancel down, which will give us x is equal to 25 over 11. And that's the answer for that. We've left it as an improper fraction, and that's probably good enough. Now, for the next of these questions, we're still solving for x. We have 2 take away 3x over 4 is equal to negative 5. Now, I don't like the fractions, so what I'm going to do is I'm going to multiply both sides by the 4, which is down the bottom, and that will cancel the 4's down. That will now leave us with 2 take away 3x on the left hand side equals negative 20 on the right hand side. Next, I've identified the 2 out the front, so to move that we'll take away 2 from both sides, which that cancels those down. Leaves us with negative 3x. Again, be careful you don't lose that negative in front of the 3x or the takeaway in front of the 3x. Minus 20 take away 2 is minus 22. And the final step here will be to divide by sides by negative 3. The negatives will cancel, the 3's will cancel, and that will leave us with x is equal to, and on the right hand side we also get the negatives will cancel down. We end up with 22 over 3 is our value of x. And for the next of these questions, I'll use a different pronoun. We'll use m take away 4 over 5 take away 5 take away 2m over 3 equals 1. Now, the way I'm going to treat this is I'm looking at the 5 and the 3 on the bottom, so I'm just going to go 5 times 3 is 15, and I'll multiply everything by 15. So I'll put the top line in brackets, 15 there, top line in brackets there, 15 there, and times the right hand side by 15 as well. Now I can cancel a few things down. 5 goes into 15 3 times, 3 goes into 15 5 times. That now leaves me with a simplified equation of 3 m minus 4 take away 5. 5 take 2m equals 15. Next we need to expand out the brackets. 3m, 3 times negative 4 is negative 12. And then we go, I'm going to treat this as negative 5, so negative 5 times 5 is negative 25. And negative 5 times negative 2m, the negative times the negatives are positive. 10m equals 15. Now we collect our like terms. We have 3m plus 10m, which gives us 13m. And we have negative 12 take away 25 gives us negative 37 is equal to 15. Next we're going to add 37 to both sides. And that will cancel that down. Leaves us with 13m is equal to 52. And next we divide by 13. Both sides need to be divided. And that will simplify down to m is equal to 4. And that there is the answer that we are looking for. The next question that we have is to find the values of m which satisfy the inequality 2 minus 3m is less than 1/2. So basically what we're going to be doing is solving this one for m. So what we need to do is we'll take away 2 from both sides to start with. It should be a 2 up the top there. Looks like a 4. Rub that all out. Taking away 2. That's the way it should be. So they will cancel down. Then we have negative 3m left on the left hand side is less than 1/2. Take away 2 is negative 1.5. Negative 1.5 is the same as negative 3 over 2. Next thing that I want to do is to divide both sides by negative 3. Now we'll have the negatives will cancel down there and the 3's will cancel down. Leaves us with m. Now the thing, when we divide by a negative, or if we multiply by a negative, we need to change the direction of the inequality. So that now becomes greater than. So we've got negative 3 over 2. I'm going to write this second term here as negative 3 over 1. And then we're going to treat it like our normal fractions just to show you what's going on. We flip it upside down when we divide by a fraction. We'll turn it into a times. So this is now m is greater than negative 3 over 2 times by negative 1 over 3 will do. Now the 3's can cancel down diagonally to leave you with 1 each. And remembering that this is negative, this term here, so we have a negative times by a negative is a positive. 1 times 1 on the top is 1 over 2 times 1, which is left on the bottom, is 2. And that's the answer to this question. In the next question, it's asking us to find the largest value of x such that 2 minus 5x is not negative. So the limit that's going to be set up for this equation is where 2 minus 5x is equal to 0. That's what we need to be looking for. Now we'll solve this one for x. So we'll take away 2 from both sides. And it leaves us with negative 5x is equal to negative 2. Next we're going to divide both sides by negative 5. They will cancel and they will cancel. Leaves us with x equals. The negatives both cancel down, so it's positive 2/5. So 2/5 is the smallest value of x that will go into this particular expression up the top here, so that it will not be negative. And that's the answer to that. Now for this particular question, we've got a father is 5 times as old as his son, and in 27 years' time he'll be twice as old as his son. We need to set up some equations from this. So the first one, a father is 5 times as old as his son, is the first bit. So that would give you the equation where if we let f represent the current age of the father, and if we let S represent the current age of the son. So we need to define those variables at the start. So the first equation we get is a father is 5 times as old as his son. So that tells us that f will equal 5s. Now I need to be careful that my s's look different to 5s and not confuse them. The second equation that we have is in 27 years' time, he will be twice as old as his son. So we have our first equation here. For the second equation, we're talking about in 27 years' time. So we're going to have f plus 27. So that's the father plus 27. He will be twice as old. So twice as old as his son. So this would need to be 27 years plus the son as well. So we're adding 27 years onto the father, we're adding 27 years onto the son, and the relationship is that the father will be twice the son's age in 27 years' time. So that's our second equation. What we would then do, I think, is we'd substitute the first equation into the second equation. So wherever we see f, we will replace it with 5s. So we have 5s plus 27 is equal to 2s plus 27. And we might scroll this up a little bit so we can keep going. So if we're in the left-hand side, we have 5s plus 27. We'll expand out the bracket on the right-hand side is equal to 2s plus 2 times 27 is 54. I'm now going to collect the like terms, so I'll take away 2s from both sides. And that will leave us with 3s plus 27 is equal to 54. I'm now going to take away 27 from both sides, which leaves us with 3s is equal to 27. And then if we divide both sides by 3, we end up with the son's age is 9. What we then do is we want to sub that into the first equation, which we'll do this up here. So we have the father is equal to 5 times the son's age. We've just worked out that the son was equal to 9, so that's 5 times 9, which equals 45. So that tells us that the son is 9 years old and the father is 45 years old. That's the answer to that one. Now, the next question we have, I've written it up there. You might need to read this a couple of times when you first encounter it. X and x plus 1 are two consecutive numbers. That's the first statement. So we have two numbers that are consecutive, one after the other, so we've got x and the next one is one bigger, so we call that x plus 1. Now, if a third of the larger number exceeds a quarter of the smaller number by 3, find the value of x. We need to set that up. So the first part it says is if a third of the larger number, so 1/3 of the larger number is going to be 1/3, the larger number is x plus 1. And that says if it exceeds a quarter of the smaller number by 3, that's going to mean that we write this as equals a quarter of the smaller number plus 3. So this is 3 bigger than a quarter of the smaller number we've got written on the right hand side. And that's the initial equation set up. We now need to solve this equation. And I don't like dealing with fractions, so what I'm going to do is something a little bit different here. Is I'm just going to times everything by 3. So 3 times that, 3 times that, and times that by 3 as well. And that's going to cancel that down and leave me with x plus 1 on the left hand side is equal to 3/4 of x plus 9 on the right hand side. The next thing I'm going to do is to multiply everything by 4 to get rid of the fraction on the right hand side. So if I times that by 4, I have to times that by 4 as well, and I'll times this by 4 as well. And what we end up doing is I'll expand out these brackets, so we get 4 times x is 4x, and 4 times 1 is 4, is equal to, now on the right hand side, the 4 down there will cancel that, so we end up with 3x plus 9 4s are 36. What I'm now going to do is take away 3x from both sides so that we can bring all the x's onto the same side. I'd look for the smallest or most negative to shift, and that will cancel that down. Leaves us with just 1x on the left hand side plus 4 is equal to 36. Next I'm going to take away 4 from both sides, and that'll get rid of that one. Leaves us with just x is equal to 32. And again, that's what you're wanting. Now we have some simultaneous equations to solve. First pair that we have is 5x plus 6y equals 17. And we also have 6x plus 5y is equal to 16. Now we need to look at the coefficients and try and make them the same. I'm going to aim to make our coefficients of x the same. So for the top line, equation 1 and equation 2, I'll label them first. For the top one, I'm going to multiply this by 6, and the second one I'll multiply by 5. Everything needs to be multiplied through. So 5x times 6 will give us 30x. 6y times 6 is plus 36y equals 17 times 6 is 102. Now for the next line, we have 6x times 5 is 30x, plus 5y times 5 is 25y, and 16 times 5 is 80. What we now want to do is subtract the second line from the first line. So we have 30x, take away 30x is 0x, plus 36y, take away 25y is 11. And 102 take away 80 is 22. Next we want to divide both of those by 11. We don't have to worry about that because it's 0. The 11 will cancel that down. We end up with y is equal to 22 divided by 11 is 2. So we take that value and we'll sub y equals 2 back into equation 1. So 5x plus 6y, but y is equal to 2, equals 17. So 5x plus 12 is equal to 17. Next we'll take away 12 from both sides. Then we end up with 5x is equal to 17, take 12 is 5. Divide both sides by 5. That cancels that down and leaves us with x is equal to 1. So therefore, for our simultaneous equations, we have x equals 1 and y equals 2, or we could write them as coordinates as 1 and 2. The next pair of simultaneous equations to solve is a little bit nastier. So this is x over 3 minus y over 4 equals 6 is the first one. And the second one, we have x plus y equals 7 as the second equation. Now, I don't particularly like fractions in the first one, so what I'm going to do is I'm looking at the denominator of the first one, that's 12. I'm going to multiply everything by 12 in this one here. So if I times this by 12, times this by 12, and times that by 12, then I can cancel a few things down. 3 goes into 12 4 times, and 4 goes into 12 3 times. So that now gives me an equation of 4x take away 3y equals 72. Now I want the coefficient of either the x or the y here to be the same as in the modified version of the first equation. So what I'm going to do is I'll just times it by 4 to cancel the x's down. So if we times this one by 4 and bring it across, we have 4x plus 4y equals 7 4s are 28. Now if we take them away, so we have 4x take away 4x is 0x. Negative 3y take away 4y is negative 7y equals, and next we have 72 take away 28, which will be 72, 52, 44. What we now need to do is we divide by negative 7. We can ignore that bit there because it's 0. Divide both sides by negative 7. The negatives cancel down, the 7's cancel down. That leaves us with y is equal to negative 44 over 7. And what we now need to do is to substitute that back into one of the first two equations. I would sub it back into the second one because it's a little bit easier, I think. So if we sub y equals negative 44 over 7 into the second equation, we have x plus negative 44 over 7 equals 7. And we can shift that to the right hand side by adding it to both sides, which cancels that down. That leaves us with x is equal to 7 plus 44 over 7. I'm going to turn 7 into a fraction of 7, so that's 7 7s are 49 over 7 plus 44 over 7, which gives us 93 over 7. And I don't think that will cancel down at all to a nice whole number. So we're just going to leave it as an improper fraction. So the answer to our question is x, put in blue, x equals 93 over 7, and y equals negative 44 over 7, or we can write it as coordinates 93 over 7 and negative 44 over 7. And that's that one. Now, next question we have a concert where tickets are $15 for adults and $6 for children. There were 1,600 people in total who attended the concert. Ticket sales ended up being $15,900. And wanting to find out how many adults and how many children attended this particular concert. So we need to set up two equations. The first one is for prices. So I'm going to let A represent the number of adults and C represent the number of children. So for my question, $15 for adults, so 15A plus $6 for children, so 6C equals 15,900. And that's going to be my first equation. The second equation that we have is the number of adults plus the number of children is equal to 1,600. Okay. What I'm going to do is I'll rearrange 2, and 2 rearranged, I'll just call it C equals 1,600 minus A, and I'll call that one 2, equation 2A. Now what I'll do is I'll substitute 2A into 1. So wherever, we'll write out equation 1, but wherever we see C, we're going to replace it with 1,600, take away A. So we have 15A plus 6 of 1,600, take away A, equals 15,900. Now I need to expand that bracket out, so we have 15A plus 6 times 1,600. Ooh, I might need a calculator for that. I only need the calculator because it's the end of the day and I can't be bothered thinking. 96 take away 6A equals 15,900. Collect our like terms, so 15A take away 6A is 9A plus 9,600 equals 15,900. And I might just slide this up a little bit. And I'll take away 9,600 from both sides, so on the left hand side we'll be left with 9A is equal to, so 15,900 take away 9,600 is equal to 6,300. Then we want to divide both sides by 9. Cancels that down, leaves us with A is equal to 6,300 divided by 9, 700 adults. Then to find the number of children, we use equation 2A. So we sub this equation 2A. And I'll keep that in blue for now so it looks a bit different. So we've got C is equal to 1,600 take away 700, which equals 900. So that tells us that we now have 700 adults attended and 900 children. That's the answer to that question. Now, for this particular question, we're told that the perimeter of this object is 76 centimetres, and we've been given a few dimensions, so there'll be a few that we have to add in. So if we look at this bit here and this bit here, it hasn't been drawn to scale obviously, but 2x plus x is 3x, which goes over here. And then for this bit here, we've got 3x plus 8 is the equivalent of this bit down the bottom. So our total perimeter will be 3x for the left-hand side, tick that one, plus another 3x for the one at the top, plus another 2x for this one here, plus 8 for this one here, plus x for this one, plus 3x plus 8 equals 76. I could have just done, it's a bit simpler than that. This is a long way, but that'll do. We're here now. So we've got all of the x terms. We've got 3 plus 3 is 6x, plus 2 is 8x, plus another one is 9x, plus another 3 is 12x. So we have 12x. And then for all of our numbers, we have 8 plus 8 is 16. Is equal to 76. So we'll take away 16 from both sides. They cancel down. Leaves us with 12x is equal to 60. And then we're going to divide both sides by 12. That cancels that. Leaves us with x is equal to 5. And that's what we were asked for. Was the original question was saying this is the shape, perimeter is 76, find the value of x. And we have just done that. We should actually put the units in, it's 5 centimetres. Okay, there you go.